Hello, everybody. My name is Xueming Lin. So I will one of the team member to present this tutorial. The whole team consists of Professor Isha Fang, Professor Dr. Kai Wang, and myself, and Wenjie Zhang. Here's the organization of this tutorial. I will present introduction using 10 to 15 minutes. Then Dr. Kai Wang will present the works on peptide networks for 20 to 25 minutes. And Professor Fang will present works on other general HINS. Okay, also using 20 to 25 minutes. Professor Wenjie Zhang will present related work and future works by 20 to 25 minutes. First, I will give HIN examples. So there are two types. There are two types of HINS. The first is a special type, is on peptide graph. So a peptide network consists of two layers of vertices, top layer and the bottom layer. In eBay, customer data typically is a peptide network. So we have the top layer customers and the bottom layer products. There are other general HINS, which consists of multiple types of vertices and multiple types of edges. DVLP network, online movie database, IBM knowledge base data, and Twitter. So these are typical general HINS. In this talk, we basically will focus on cohesive subgraph search. So this is a very fundamental research topic in network science and has been studied over 50 years with thousands of papers. So it's actually this actually can support a wide range of real applications. Most existing works focus on homogeneous networks. So the models and the algorithms cannot be applied to HINS. We need to develop new models and algorithms for HINS. The main challenges are multiple types, huge data size, and dynamic data. So later in this tutorial, my colleagues will address these issues. There are many applications of cohesive subgraphs on HINS. Fraud detection, group recommendation, heterogeneous entity detections, community search, network modeling and analysis, network visualization, and team formation. So I will address some of them in my talk. The first one is about user item network. So we want to detecting click farming actions in Taobao and other e-shopping platform. People from time to time, people want to do click farming. So this is actually not something new, right? We have a long history of click farming. Okay, so this is what people will do. They click a product. So this action will be recorded. So if you put a product into your shopping list or you purchase it, that'll be recorded. And then when you ranking products, it's based on the popularity among the users. So if you click more, the items will be ranked higher. This is actually the reason why we have click farming. And the challenge is in such applications, there are huge data. So we have billions of buys and products, and we have 10 plus billions of transactions and dynamic data. And we need, we need to compute we need to figure out such click farming, as quick as possible, right? So actually a very popular method is to compute bipeptide, by click on bipeptide graphs. Okay, so for the previous application, we actually have collaborated with Alibaba, and we put the software online in the last couple of years. So the result is very good. So we can because the computing power, right? Because the computing power is getting much better, so the efficiency can be increased about 40–50%. So the next one is about group recommendation. So we usually want to do the group recommendation among the customers. So here's one example: user movie network, right? So we want to detect alpha beta call. So this is so-called alpha beta call. In unipopulated graph, we could have K call, so on so forth. But in bipeptide graph, we need to have degree constraints on both sides. So one is alpha, the other is beta. This is also an application of bipeptide graph. Okay, so we want to analyze heterogeneous genomic scale data by enumerating maximum by click. So here's the scenario: we compute a bipeptide graph. We compute by click. Then with the by click, we form a deck. We form a deck for further analysis. HINS analysis can also be used in network visualization. So we know visualization basically want to convey the clear ideas to the users. So in this case, the left-hand side is a network. So we want to do the projection, right? See, in this case, for instance, we want to do the projection on users. Then with the right-hand side, we actually calculated two critical nodes, Ruth and Opel. So these two nodes are actually the bridging nodes. So if you remove those two nodes, the network will be divided into two parts, right? So if you use the computation on HINS, we can come up with this, right? Finally, we can see the applications on DBLP networks. So we can, in DBLP networks, typically there are different types of nodes. Like in this case, the core number equals 3, core number equals 4, core number equals 5, and so on and so forth, and different ages. So we can we can display those different types of edges and the nodes, right? By the calculation, firstly by the calculation, and then we use different colors to display them. Right, so what we'll cover in this tutorial, we'll cover core, we'll cover truss, we'll cover click, we'll cover connectivity, we'll cover connectivity-based cohesive subgraph, we'll cover density-based subgraph, and others. Okay, so I will pass this talk to my colleague, Dr. Kai Wang.